Hello everyone, I'm Professor Amit Vaid from Marwadi Education Foundation's Group of Institute Rajkot, Gujarat, India. Today I will be discussing about the subject what is electromagnetic field theory. The chapter what we are going to discuss today is vector analysis, and I'm going to discuss the important topic, that is spherical coordinate system. So let us again look at this. This is my sphere over here, right, which is having a radius r, which is from the origin. So you can understand that everywhere when I will measure radius on any of the point on the sphere, the radius will remain the same. So this outer part, it is called as a r is equal to constant. So as you can see here, that if I will change r, then the volume of this sphere will change, or the size of the sphere will change. Now the second coordinate what I have to use here, it is, let us say that I am just putting one point which is at the surface of the sphere onto this xyz plane. So then I can say that this xyz plane has got the three coordinates which are known as r, theta and phi. So r is the distance what is available between this point of interest and the origin, and the theta, it is the angle which is there in between the positive z axis and the line which connects origin to this point of interest. And if I take the projection of this line that is having the radius r on the xy plane, so I am getting this as the projection of this r onto the xy plane. So the angle what this projection makes with the positive x-axis, it is the angle phi. So looking to again this part, we can see that if I change the angle theta, then I will be able to change the shape of this cone. If I change the angle phi, then the angle between the x-axis and this plane what comes, that will change. So if we look at the limits, so r, it is taken as r has a limits which is from 0 to infinite, because r is a distance, so it cannot be negative. So we'll start always from the 0, and maximum value for the distance is infinite. If we take the angle theta, it is always measured from positive z-axis, so whether it is measured from this side or it is measured from this side. So ultimately the range of the theta what I get, it is always from 0 to pi or 0 to 180 degree. While when we talk about the phi, we measure this phi in the anticlockwise direction from the positive x-axis, and that's why usually the range of phi, it is taken in between 0 to 360 degree, or it is taken in between 0 to 2 pi. So moving ahead, now let us have the conversion from the spherical coordinate system into the Cartesian coordinate system. So I assume that I already have this coordinates, that is r, theta and phi is available, and I want to find out x, y, z. So to have this, first of all, let's look at again this point which is a point of interest. So from origin to this point of interest, let us say this line is given as OB, and this OB is equal to r, as we already taken. And this OB line makes an angle theta with respect to the z-axis. And if I take the projection of OB on xy plane, then this OC is called as a projection of OB on xy plane. And since this angle is theta, the projection of this OB on xy plane, it will be cosine of angle 90 minus theta, and that is equal to sine theta. So I am getting this line OC is equal to sine theta. Now look, if I look at this again, this triangle which is given as AOB, it is mentioned here, this is AOB. So in this case, if OB is r, this angle is theta, then projection of r on the z-axis is going to be r cos theta. So here I am taking that z is equal to r cos theta. That is my first conversion what I am getting. Similarly, if I want to get the second conversion, I need to take the projection of OB onto the xy plane, and that is equal to r sin theta. How I get r sin theta? So for that I have taken this triangle here. That this triangle is BOC triangle. The angle O is 90 minus theta. So projection of r on the x-axis, it is r cos of angle whatever it is, and that I get it as r sin theta. So again now I am getting this projection as r sin theta. This r sin theta is projection of r which is lying above the xy plane, right, on the xy plane. Now if I want to take projection of this length onto the x-axis, then it should be cosine of angle into the length. So length over here is r sin theta, and this will be r sin theta into cosine of phi. So here I am getting x is equal to r sin theta cos phi. Similarly, if I want to get projection of this line onto the y-axis, then it has to be r sin theta into angle between this projection and y, and that will be 90 minus phi, so it will come as r sin theta sin phi. So here I am getting conversion from the spherical coordinate to xyz. Now if I want to go on the reverse side, that is I want to convert now xyz into r theta and phi. So first of all, if I take vector r, so you can see here that r is made out of the three vectors, vector x, vector y and z. So I can say that the magnitude of r can be taken as under root of x square plus y square plus z square. Or I can also get the same value by taking the square of the 1 plus square of the 2 plus square of 3. So I will get here it as a x square plus y square plus z square, and that will be equal to, over here if I will simplify this, then I will get because cos square theta plus sin square theta will be 1, cos square phi plus sin square phi will be 1. So I will be getting here this as r square, and so I will get relationship r square is equal to x square plus y square plus z square. Similarly, if I look at the equation 1, which is z is equal to r cos theta, so I can say that cos theta is equal to z by r, and so theta is equal to cos inverse of z by r. Similarly, I can say here that if I take 3 by 2, so r sin theta will be cancelled out, and sin theta upon sin phi upon cos phi will be tan phi, and that is equal to y by x. So I can get phi is equal to tan inverse y by x. So here I am able to convert spherical to Cartesian as well as Cartesian coordinate to spherical coordinate systems. Now we need another information, which is actually if I take an incremental cube at the surface of this sphere, then what should be its length? So here we are having one length, that is radius r. So r itself is a distance, so I can say that dr is the length here. Now if I look at this part, then here I am getting this angle as a d theta. So if I take d theta, then I am getting it as an angle, it is not my length. So if I want to get a length, I should take it as a r into d theta. Similarly, if I want to find out the third length, I have to take the projection of r on the xy plane. So this projection is again, as we had seen, that it is r sin theta, and angle over here is d phi. So I am getting my third length as r sin theta d phi. Now if I want to take three surfaces, then naturally it should be multiplication of the two lengths. So I am getting first length as surface as r d theta dr. Second surface I can get here, it is r square sin theta d theta d phi, and the third surface I can get here is in between, there is r sin theta dr d phi. Now I can get volume by multiplying these three lengths, and that is r square sin theta dr d theta d phi. Now let us take that how we can get the dot product between the axis from the spherical coordinate, that is ar, a phi and a theta, and its product with the Cartesian coordinate system, that is ax, y and az. This will help us to convert one coordinate system into another one. So let us look at this. So we are having first of all, both of these are orthogonal systems. So ax, ay and az, they are 90 degree to each other. Similarly, ar, a theta and a phi should also be 90 degree to each other. But let us understand the behavior of this. So here ax and ay, let us say that they make an xy plane. So az is perpendicular to xy plane. Now ar is at angle theta with respect to az, so it means that it is making an angle that is 90 plus minus theta from in between ar and xy plane. If I look at a phi is in directly xy plane, right? So and it is making an angle phi with respect to ay. Now if I look at a theta, so a theta has to be perpendicular to ar. So here ar is having an angle theta with respect to az. So a theta is also making an angle theta with respect to y-axis. And a phi, again it is in the same direction as that of xy plane. So here you can understand that if I just rewrite this, so ar comes along this axis, a theta is 90 degree to it, and whatever plane is made by ar and a theta, perpendicular to that I am getting a phi, and this a phi axis, as you can see here, that it is along xy plane. So with this information available to us, let us again make it clear that AR is above XY plane and A theta is below XY plane. Now AR is having an angle 90 minus theta with respect to XY plane. So projection of AR will be taken as cos of 90 minus theta, and that is equal to sin theta. And projection of A theta on XY plane will be simply taken as cosine of angle between them, and that is equal to theta. So cos theta will be the projection of A theta on XY plane, and projection of AR on XY plane will be equal to sin theta. And if I look at A phi, it is already in XY plane and it makes an angle 90 with respect to AZ, right? So looking to this, the projection of A phi on AZ would be 0. Now let us take a dot product between AR and AX, right? Similarly AR and AY and AR and AZ. Now we know that dot product, it ultimately gives the projection of vector along the side of the other line. So if I want to find out the dot product between AR and AX, then naturally it is taken as the AR magnitude, that is 1, into AX magnitude, that is also 1, and angle between both of this. Now if I want to take the angle, I cannot directly take. So what I will do is I will take the AR axis as it is, I will take its projection onto the XY plane, and that projection, as we already seen, that it is equal to sin theta. So the projection of sin theta length on the x side will be my dot product between AR and AX. So this projection is already sin theta, and if I take its projection on x axis, it will become sin theta cos phi. So I am getting AR dot AX as sin theta cos phi. Similarly, AR dot AY, so again I have to take this length as sin theta and its projection on y axis is sin phi, so it will become sin theta sin phi. And if I take AR and AZ, already the angle between them is theta, it can be directly evaluated. So AR dot AZ, it is equal to 1 into cosine of theta. Now let us evaluate the second axis, that is A theta. So A theta is below the XY plane, making an angle theta. So its projection on XY plane will become cos theta. So cos theta is the projection of A theta on the XY plane. Now if I want to find out the projection of A theta on AX, then naturally it will be taken as cos theta cos phi. Projection of cos theta on y axis will be cos theta sin phi, because this angle over here is phi, and the angle between AZ and A theta is 90 plus theta. So AZ dot A theta comes out as a cosine of 90 plus theta, and that is equal to minus sin theta. Now let us take the third one, that is now A phi axis. So phi axis, it is already available on the XY plane, right? So there is no need to find out any projection for A phi, but we can say that angle between A phi and AX is 90 plus phi here. As you can see, this angle is 90 degrees and this angle here is phi. So I can directly get A phi dot AX is equal to cosine of 90 plus phi, and that is minus sin phi. Similarly, AY dot A phi, it is going to be cos phi, because angle between them is phi, and AY dot AZ, it is 0, because A phi and AZ, they are at 90 degree, because A phi is lying in XY plane. So here I am able to get this all are the spherical axis and these are the rectangular axis. So I am able to get what is AX dot AR, AY dot A theta, and so on. So I am able to get all the dot product between the cross system, that is in between spherical coordinate system and Cartesian coordinate system. So that's it, what I have to talk about the spherical coordinate system. The next time we'll discuss about the electric field intensity. So till then, bye to everyone.